Hi friends, welcome to my YouTube channel Knowledge Sharing. Today I'm going to share you all about Class 7 NCERT Science Chapter 13 Motion and Time. So, what is motion? The continuous change of position of our body with respect to our surroundings is called motion. Examples of motion are a man walking on the road or a bird flying in the sky, etc. We can observe that in this physical world, some objects are always in rest while other objects are always in motion. So, what is rest? A body is said to be at rest when it does not change its position with respect to its surroundings. Example, a book lying on a table. Rest and motion are relative terms. Let's see how. I am drawing a train. I'm traveling the train and there are two passengers in this train. Let's mark it as passenger 1 and passenger 2. And there's also another person who is standing on the platform. This is the train. This is the platform. There's a person who is standing on the platform. Let's name it as passenger 3. So there are three scenarios here. The passenger 1 and passenger 2 with respect to passenger 3. Respect to passenger 3. So the passenger 1 and passenger 2 are traveling in a train and the passenger 3 is standing on the platform and is sitting on a bench. The passenger 1 and passenger 2 will be at motion with respect to the passenger 3 who is sitting on a bench in a platform. There is another case too. The passenger 1 respect with passenger 2. The passenger 1 will be at rest, will be at motion with the passenger 1 will be at rest with respect to the passenger 2 because there is no change of position of their surroundings. Case 3, when the passenger 1 and passenger 2 with respect to passenger 3, when he starts running 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 so the passenger 1 and the passenger 2 will be at rest with respect to the passenger 3 who starts running on the platform because there's a change before, so they both will be at rest. This is the example of the rest and motion relative terms. There is also another type of motion in the particles. The random motion of tiny particles suspended in a liquid or fluid is called as Brownian motion. It was founded by Robert Brown, a Scottish scientist. The Brownian motion was named after his name Robert Brown. Now let's discuss about slow and fast moving objects. In this physical world, there are many vehicles which travel at a great speed and some vehicles which travel at a low speed. For example, a car is always at a greater speed than a bicycle. If you wait at the bus stop and watch both vehicles start at the same time, you will be able to identify that which vehicle is moving fast. Now let's discuss about speed. Speed is the distance traveled by the body in a unit time. The fast moving objects have greater speed while the slow moving objects have less speed. So speed formula is equal to distance by time. Units of speed. How to express speed? There are many units of speed which are used to express speed. The basic unit of speed is meter per second. Different living beings have different speed. For example, the speed of the horse is measured in kilometer per hour while the speed of the ant is measured in centimeter per second. Now speed is equal to, now how to remember meter per second or kilometer per hour? Now speed is equal to distance by time. Now I am taking distance as meter and time as seconds. So this is by meter per second. we can easily identify like this. Now even again, distance is equal to speed into time, and time is equal to distance divided by speed. These are the formulas for the speed, distance and time. So when we travel in a vehicle in some places, in suppose in a highway, the vehicle moves at a greater speed, and when we travel in a traffic jam, the vehicle moves at a lower speed. So how can we measure speed in this? So this is called as average speed. Average speed is calculated by the total distance traveled by the total time taken. I'll give an example for an average speed. A car traveled 20 kilometer in the first hour and 30 kilometer in the second hour and 40 kilometer in the third hour. So average speed is equal to total distance by total time, that is equal to 20 plus 30 plus 40 by, in each, don't think that it traveled in 2 hours 30 kilometer, it traveled in each hour, this is the second hour, so take it as 1 plus 1 plus 1 is equal to 90 by 3, which is equal to 30 kilometer per hour. This is an example of average speed. Now, while giving the example for a unit of speed, I took meter per second. But now I am here using kilometer per hour. Why? Because my distance is measured in kilometers and my time is measured in hours. So I am taking it as kilometer per hour. So now how to convert kilometer per hour into meter per second? Now 1 kilometer is equal to 1000 meter. 1 hour is equal to 3600 seconds. So 1 kilometer per hour is equal to 1 kilometer per hour is equal to 1000 divided by 3600 is equal to 5 by 18 meter per second. Now if I want to convert 72 kilometer per hour into meter per second, I can take it as 72 into 5 by 18. Now by the same way, how to convert meter per second into kilometer per hour? The same, one hour is equal to 3600 seconds, 1 kilometer is equal to 1000, 1 kilometer is equal to 1000 meter. So 1 meter per second is equal to 3600 divided by 1000 is equal to 18 by 5 kilometer per hour. So if I want to convert 72 meter per second into kilometer per hour, I can take it as 72 into 18 by 5. Now let's discuss about distance time graph. So what is distance time graph? A distance time graph is used to show the total distance traveled by the body in a unit time. The distance time graph is used to tell whether the body is said to possess uniform or non-uniform motion. So what is uniform and non-uniform motion? There are two types of motion: uniform motion and non-uniform motion. When the body covers equal distances in equal intervals of time, the body is said to possess uniform motion. When the body covers unequal distances in equal intervals of time, the body is said to possess non-uniform motion. Now I will give you an example of distance time graph for uniform motion. X-axis and y-axis. Now here I am going to write time in seconds. 1 second, 2 seconds, 3 seconds and 4 seconds and 5 seconds. Now this is distance in meters. Distance in meters. 5 meter, 10 meter, 15 meter, 20 meter, and 25 meter. Now a body covered 5 meter in 1 second, a body covered 10 meter in 2 seconds, a body covered 15 meter in 3 seconds, and a body covered 20 meter in 4 seconds, and 25 meter in 5 seconds. So this is all, and it is depicted as the same uniform motion. It is at the same. Now if you now 5 divided by 1 is equal to 5. 10 divided by 2 is equal to 5. 15 divided by 3. Now we are calculating the speed. So speed formula is distance divided by t. So 5 divided by 5 is the distance, 1 is the second, 5 divided by 1, 5 meter per second, 10 is the distance, 2 is the time, 2 is the time in seconds. So 5 meter per second, 15 divided by 3 is equal to 5 meter per second. Again 20 meters, 4 seconds time. 20 divided by 4 is equal to 5 meter per second, and 25 meters and 5 seconds in time is equal to 5 meter per second. So you can observe that a man covered all the distances in equal intervals of time. All the speed is constant. So this is the example of distance time graph for uniform motion. Now I'll give an example of distance time graph for non-uniform motion. I am drawing a graph. X-axis, y-axis. Again here time in seconds. Time in seconds. 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds, 7 seconds. Now distance in meters again. Meters. 5 meter, 10 meters, 15 meters, 20 meters, and 25 meters. Now a man travel 5 meters in 1 second, 10 meters in 3 seconds, 15 meter in 2 seconds, and 20 meter in 4 seconds. Now it is not constant, it is going at a different way. So this is an example of non-uniform motion. The speed is not constant. So this is an example of distance time graph for non-uniform motion. Sorry friends, this is not the correct notation. We can take the 15 meters as in 5 seconds. Now I'm going to depict distance time graphs without any units of speed. For example, for uniform motion, we can depict, now this is in seconds, time in seconds. Now our distance in meters. Distance in meters. So this is uniform motion and non-uniform motion. Now again time in seconds, distance in meters, as like this. And now for rest, how to depict the distance time graph when the body is at rest? We can depict it as, now time in seconds, distance in meters. That's it friends. I will meet you in the next video with a new topic. Thank you friends. If you like this video, please like, share and subscribe. Thank you friends.